Hello everyone, welcome to my channel. In today's session, we'll learn how to delete a node at the end of a linked list. If you have not subscribed to my channel, please do subscribe and support me. To learn more about data structures, please do visit my data structures playlist. Before writing the C code, let us explore the concept of deletion. There are two cases here. In the first case, as you see on the diagrammatic representation, our linked list will be empty. So in an empty list, we'll not be able to perform deletion. So we will just display that deletion can't be performed. In the second case, there will be some nodes that are already present in the linked list. We are supposed to delete the last node. So how do we find the last node? So we know that the last node's next part will be having null. So we will be searching each node and we'll find whether the next part is null or not. If we'll have to traverse till we find the last node. So after finding the last node, we have to perform deletion. With this deletion, the process is not yet over. We have to change the link of the previous node as null. So we have to traverse from the beginning and find the last node, delete the last node and change the link of the previous node as null. So here in singly linked list, we have to have an extra pointer to keep track of the previous node. So this is the entire process of deletion at the end. So let us now write the C code for this particular concept. As you know, a node in a linked list is represented using structures. So we'll first write the structure definition of a node. So how do we write that? Struct will be my keyword, node will be my structure name. Each node will be having two parts. The one is the data part. I assume my data part as a set of integer values. So I will be representing with int as my data type. The second field is a pointer variable. I name that pointer variable as next. So this pointer variable will be referring or pointing to a node again. Okay, so I am going to represent it using self-referential structure. As you know, the structure definition should be terminated. We'll now start writing the main function. As you know, main is the starting point of any C program. So within main function, we'll create structure variables. So how do we create that? Struct will be my keyword, node will be my structure name and followed by my variable name. Here I'm going to declare a pointer variable called head. Okay, this will be storing the address of my first node. I'll be initially assigning my head value with null, which means or which implies my list is empty. The scenario here is to perform deletion at the end. There must be some nodes that are present in a linked list before deletion. So we'll call any of the insertion routine here. I prefer calling append. So I'm here calling append 3 times, which means there will be 3 nodes present in my linked list. If you wish to know about various insertion process, please do visit my data structures playlist. Let us now call delete function. So delete underscore n will be my function name. I will be passing the reference of head. So whenever there is a change in the logical structure on doing any operation, we'll be passing reference. So as you know, after deleting a node, there will be a change or modification in the logical structure. So I'm passing reference here. Now let us try the function definition. Void will be my return type of my function. So delete underscore end will be my function name. So I will require one parameter. As you know, to hold on the address, I need a pointer variable. So head itself is declared as a pointer variable. So pointer to pointer, the variable name is p here. It will be of type struct node. So let us write the function definition. Let us now declare the necessary variables. So we require two variables. One is the temporary variable which is required for traversal and the previous variable for tracking the previous node. Let us first assign my temporary variable to the content of head, okay, for traversal. Okay, as you know, linked list is a sequential access one, so we have to traverse from the beginning. So this particular temporary variable will be helping us to do the traversal. So initially my temporary variable is pointing to the first node. As you can see, it is temp. Okay, so our process is to find the last node. How do we find that? We have a clue that our last node will be having the address null. Okay, the last node's next pointer will be having the address null. So we are going in search of that. So we require a loop for that. So I'm going to check each node's next part. Okay, so temp of next. I'm sorry, it is temp of next. I'm going to check whether it is equal to null or not. If it is equal, I'll stop. So I have to run till not equal to null. Okay. So what did I do? If it is not null, I will be moving my pointer to the next node, isn't it? So how do I do that? Temp is equal to temp of next. This line of code will be helping me to move from one node to the other. But I've told you we have to keep track of the previous node's address also. How do we do that? So before moving on to the next node here, we have to assign previous with the temporary variable's address. Okay, so this will be helping us to track the previous node also. So I'll show this working. Okay, so initially temp is pointing to the first node as shown in the figure. Okay, I'll check temp of next is not equal to null or not. As you can see, it is not equal to null. My condition is true, isn't it? So I'll get inside the loop. I will be assigning previous to temp now. So what will happen? My previous will be pointing to the first node now. Okay, what is my next node? I'm assigning temp's next part. Okay, temp's next part is 30x. Okay, to temp again, which means for my temporary variable from here will be moved on to the next node. Okay, I'm going to check the loop again with the updated temp value, which is nothing but 30x. 30x next pointer is not equal to null, it is 50x. So I'll get into the loop. I'll be assigning my temp to previous. So previous now is updated. So it is now referring to what? The second node, that is previous. Now what I'm trying to do in the next line, that is this line. So I will be moving my pointer to the next node. So temp of next is 50x. 50x is reassigned to temp, which means my temp will be moved here. As you can see, again my loop will be executed, right? So temp of next not equal to null. It is equal to null here. So the condition fails. We will be coming out of the loop. Once after finding the last node, we are supposed to delete the last node, isn't it? So we have to delete this. So with this, the process isn't over. We have to change the previous node's next pointer to null. So these are the two major changes that you have to do to finish this routine. So let us now write. So what should I do? I should change my previous node's next pointer with the value null. I should assign the null as to the previous node's next pointer. So after this, what should I do? As you know, we are dealing with dynamic memory allocation. So the unwanted values should be freed. Okay, that can be done with the help of free, which is a dynamic memory allocation function. So what should we free? The location which is pointed by the variable temp. Okay, that's all. This routine is over. Very simple. So we have to find the last node. We need a loop for traversing and finding the last node. Once after finding the last node, we have to delete that node and change the previous node's next pointer as null. The code can be visualized only if you write display function. I have written display function here. If you wish to know about display function, please do visit my data structures playlist. So I will be calling display function here in the main function by passing head. So after appending, I'm displaying, and after calling delete at end, I'm again displaying. So let us check whether the code runs fine or not. I'll click on execute, compile and run. So as you can see here on the screen, I've called append 3 times, right? So 21, 35 and 55 is appended, and you can see my value is displayed after deleting the last node, that is 21 and 35 is being displayed. So it is a very simple routine. Please try and execute this code. Thank you for watching. If you like my videos, please do subscribe my channel and support me. I'll be meeting you in the next video. Thank you all.